You know, there's this quiet revolution happening right now, deep inside the data centers that power our modern world. It's a fundamental shift, moving us away from the age of electricity and into the age of light. So let's dive into how this one simple change is completely rewriting the future of artificial intelligence.
It sounds almost too simple to be true, doesn't it? I mean, we think about AI as this world of complex algorithms and mind-bogglingly huge data sets. But what if the real thing holding it back, the true bottleneck stopping the next big breakthrough, is just the physical, humble copper wire that connects one chip to another?
So to really get why a simple wire is such a huge deal, we first need to talk about AI's, well, its incredible appetite. Think about it. Every single time you use a generative AI, you're tapping into a system that is just devouring enormous amounts of power and trying to move staggering volumes of data around. And those copper wires connecting all the chips, they're really struggling to keep up. It's creating this massive digital traffic jam that's threatening to slow AI's progress down to a crawl. So, how does data actually get around in a data center right now? Well, it's a story all about electricity, copper, and, as it turns out, a surprising amount of inefficiency.
And this slide just lays out the whole problem perfectly. On the left, you've got the old way. An electrical signal has to take this long journey from the main chip all the way across a circuit board just to get to this separate, kind of clunky plug-in module that finally turns it into light. But on the right, that's the elegant future we're going to explore, where light is born right next to the processor. Now get this, that journey across the circuit board we just talked about, it can be up to 16 inches long. That might not sound like a lot, but in the world of microelectronics, that is a marathon. And over that distance, the signal gets weaker, it loses energy, and it generates a ton of waste heat. It's basically the difference between shouting across a crowded room and just whispering directly in someone's ear. Okay, so how do we fix this mess? Well, the answer is a truly revolutionary technology, and it's called co-packaged silicon photonics. So the first piece of this puzzle is silicon photonics. For the longest time, silicon, the stuff in all our computer chips, was great with electricity, but just awful at anything to do with light. But, and this is the really cool part, through some brilliant engineering, scientists figured out how to basically fuse special materials that are great at creating light directly with the silicon. What that means is we can now make and control light using the same exact cost-effective manufacturing we use for every computer chip on the planet. And then comes the second key part, co-packaging. This is where it all comes together. We take those tiny light engines we just talked about, and we fuse them, we package them right onto the same unit as the main processor chip. That 16-inch journey, it gets shrunk down to just a few millimeters. The light source is now literally part of the chip itself. All right, so we get the tech now, right? But what does it actually do? What's the payoff here? Well, the results are nothing short of dramatic. First up, power. According to NVIDIA, this direct integration slashes power consumption by 3.5 times compared to the old way. In the world of massive data centers where every single watt counts, that is a total game changer.
It's also faster to build with. I mean, it makes sense, right? Because you're dealing with a single integrated component instead of a whole box of tiny separate parts. It just makes deploying these systems so much more streamlined.
But what about reliability? Does this newfangled tech actually work? Oh yeah, Broadcom, working with Meta, tested these systems and hit 1 million device hours of operation without a single connection failure. To put that in perspective, that's like having a perfect phone call with 0 dropped words for over 100 years. That is just an incredible level of stability.
And hey, don't just take my word for it. This quote from Broadcom's Near Margaret really says it all. This isn't some science fair project anymore. This is proven technology that's ready to go big time. But of course, there's always a catch, right? This leap forward creates a new, and let's be honest, a very predictable problem. When you pack this much power and light into such a tiny space, you are going to generate an intense amount of heat. So the critical question becomes, how on earth do you keep this thing cool? Because if you can't manage the heat, all those amazing performance gains we just talked about are completely meaningless. They would literally just go up in smoke. The answer is another really elegant piece of solid-state physics called a thermoelectric cooler, or a TEC for short. You can think of it as a tiny, silent digital heat pump. It has absolutely no moving parts. You just apply an electrical current, and it actively moves heat from its cold side to its hot side. And you can see exactly how it works right here in this diagram.
The TEC sits right on the chip, pulling heat away from all those critical optical components and moving it to a heat sink where it can be safely carried away. This prevents what's called thermal crosstalk, which is basically where heat from one part messes with another, and it ensures the whole system runs cool and reliably.
So, you see, what we're talking about here isn't just a new chip. This is the beginning of a whole new era in computing, and it's being built on a massive industry-wide collaboration. I mean, just look at this ecosystem. You've got giants like TSMC fabricating the actual silicon, Foxconn handling the assembly, Lumentum providing the lasers, and Corning making the fibers. This is a coordinated global effort to completely rebuild the plumbing of the internet.
And it's coming really soon. According to industry analysts at DigiTimes, the major commercial breakthrough for this technology is expected in 2026. This isn't some distant future. It is right around the corner.
So let's bring it all home. What does this all mean? Well, it means more powerful and capable AI, finally freed from today's data bottlenecks. It means more sustainable and efficient data centers, which is a huge win for the planet. And it lays the foundation, the scalable infrastructure, for innovations we can't even imagine yet.
We are fundamentally changing how information moves at the smallest possible scales, and that is unlocking a whole new level of computational power. So the question isn't if AI will break new ground, it's what it will conquer first. With the chains of that old copper wire finally broken, is it going to be creating new medicines, designing new materials, or maybe something else entirely?